Hello guys, and welcome back to chemistry class. It's chemistry. All right, and today we are going to continue our discussions on oxidation and reduction reaction, and specifically we are going to learn how to assign oxidation number to organic compounds. Right? How to assign oxidation number to organic compounds. All right, so it's also very important that we learn how to assign to assign oxidation number to organic compounds. Right, please know that this video tutorial, of course, is brought to you by the O3Schools JAMB app. It is all you need to succeed in your exam. Quickly, it has some wonderful features and modes, like there's a study mode, there's an exam mode, there's a practice mode, there's a mock mode. You can take as many mock as much as possible. All right, and of course, there are some other interesting and wonderful feature like the classroom feature, where an AI powered tutor is there to interact with you as you try to interface with questions on the app. All right, you can chat with the app, you can chat with the chatbot. All right, and it will be reply you. The chatbot knows the exact question that you are on, so it knows everything around that topic that you are answering a question on. So anything you ask that chatbot, it will be there to guide you. To not tell you the direct answer, because if it tells you, you will not learn. All right, so it can lead you to the answer, so that you learn a lot of things leading to the answer, thereby expanding your knowledge. Also, another wonderful feature called the question search feature, where you can search for questions by topic. All right, and then we also have the UTME challenge, which is a bomb. The UTME challenge is a challenge that will conduct for all students that are writing JAMB for a particular year to win a lot of interesting prizes, and as well three other things. Like one, you'll be able to see your score after every challenge, as we conduct this challenge every Saturday till 1 week to the JAMB exam. All right. Number two, you get used to how JAMB sets their question. Number three, you build your confidence toward the exam. Know that this app is available for both Android phone, for iOS devices soon, and for your computers. In case you want to practice without distractions, all right, you can download the app for your computer. All right, if you want to get the app for your computer, simply send a message on WhatsApp on this number 09121515246. Once you send a message on this number, all right, we'll send you a link that I can use to download the computer version. Please know the activation of this app is one time. You pay only once for your activation, and it remains forever activated for a particular version. All right, so please know the activation is 3,000 naira. Feel free, pay for your activation. Send a message to this number on WhatsApp once you have paid. And of course, or if you don't know how to pay, also send a message and we'll be able to guide you. Okay, so let's quickly see how to assign oxidation number to organic compounds. Now, when assigning oxidation number to organic compounds, bonds are hypothetically broken. All right, bonds are hypothetically broken, and then we remove all the atoms surrounding the carbon atom. All right, by assigning oxidation number to other elements in organic compounds, like hydrogen. All right, +1. All right, we assign oxidation number to what? To all. We remove first of all, we break the bonds. All right, and then we remove all the atoms surrounding the carbon atom by assigning oxidation number to what? Other elements in the in other elements in the organic compound, like hydrogen +1, like of course oxygen -2. All right, like the halogens. Some people will say X, right? -1. All right. So this is what we do. We assign oxidation number to the to the elements, all right, in the organic compounds. Like for example, hydrogen, we assign oxidation number of +1 to it. Like oxygen, we assign oxidation number of -2 to it. Like halogens, we assign oxidation number of -1 to it. All right. So that means to say, after we have done this, we can now determine the oxidation number of the central carbon atom. All right, so let me go over it again. I said when assigning oxidation number to organic compounds, bonds are hypothetically broken, and then we remove all the elements or all the atoms surrounding the carbon atom by assigning oxidation number to other elements in organic compound like hydrogen, oxygen, halogens, giving this what oxidation numbers, and then we can now determine the oxidation number of the central carbon atom. In other words, what we are saying is that when we are assigning oxidation number to organic compounds, we're breaking the bonds first, and then we would want to decide, after removing all the atoms by assigning this oxidation number, we would want to decide what charge the carbon atom will acquire if the carbon atom was an ion, if it were an ion. All right, now the following will be very useful. The following will be very useful when assigning oxidation number. But know first that if in an organic compound we have more than one carbon atom, all right, if we have more than one carbon atom, what we do is that we'll determine the oxidation number of each of the carbon atoms, all right, separately. We determine the oxidation number of each of the carbon atom separately. All right, now let's see what a useful guide that will help us when assigning oxidation number. If you have a carbon to carbon single bond, or have a carbon to carbon double bond, or have a carbon to carbon triple bond. All right, now know that there's no difference in electronegativity between these two carbon atoms. There's no difference in electronegativity between these two carbon atoms, either carbon to carbon single bond, carbon to carbon double bond, or carbon to carbon triple bond. And that means that once we break these bonds, once we break the bonds, all right, there will be no charge created for the carbon atom. It will not give the carbon atom any charge. So whenever we see carbon to carbon single bond, carbon to carbon double bond, carbon to carbon triple bond, we ignore the oxidation number or charge there. We ignore the charge, right? We say that the charge there between these two carbon atoms like this is zero. All right. Now, when carbon is bonded to, let's say, hydrogen, carbon is bonded to to hydrogen. All right. So what we do, the oxidation number of carbon is -1. This one is +1. All right. Now, of course, the reason why the oxidation number of carbon is negative when it is bonded to hydrogen is because carbon is more electronegative than hydrogen. So carbon can also bond with other elements, or can bond with oxygen, can bond with nitrogen, can bond with halogens. All right. So irrespective, all right, even carbon to carbon double between the oxygen atom, carbon to carbon triple bond between the nitrogen atom. All right. The oxidation number of carbon here will be Will be +2. While oxygen is -2. Here it will be +3 for carbon. While oxygen here is -2. All right. While nitrogen here is -3 rather. Now, having seen this, to explain this better, what I'm saying is that we ignore carbon to carbon bond, either double, single, or triple. All right, we ignore them because there is no difference in electronegativity between these two carbon to carbon single bond, these two carbon to carbon double bond, and these two carbon to carbon triple bond. So breaking the bonds, we know lead to a charge on the carbon atom. Now, when carbon is bonded to hydrogen, carbon will have an oxidation number of -1. The oxidation number or charge on it will be negative because carbon itself is more electronegative than hydrogen. That means hydrogen is more electropositive than carbon. You get? Now, carbon will have a positive charge when it is bond when for example C to O, C to N, C to X. Remember that X represents halogens here. Halogens, that is the elements in the group 17 or group 7A of the periodic table. All right. So now, when carbon will have a positive charge when it's bonded, when carbon to oxygen, carbon to nitrogen, or carbon to a halogens bond is broken. Why is that? It will have a positive charge because carbon itself is less electronegative than most of the other elements in organic compounds. Carbon is less electronegative than most of the other elements in organic compounds. All right. Now let's also use an example to push this further. Remember, I've told you that when there are more than one carbon atoms in an organic compound and you want to determine the oxidation number, first of all we need to determine the oxidation number of each of the carbon atoms. If there are 3 carbon atoms, they will both have what? 3, what? They will have 3 oxidation what carbon, will have 3 oxidation what number of states. All right. If there are what 4 carbon atoms, each of them will have what? An oxidation what number. Each of the 4 carbon atoms will have what? An oxidation what number. So let us show an example to drive this home. Okay. So let's see, for example, the simplest. Let's say propane. Let's say propane, number 1, CH3, CH2, CH3. All right. If I are given something like this, I want to determine the oxidation number of what? Of the central carbon what atoms. Remember, there are how many carbon atoms? How many carbon atoms here? There are 3 carbon atoms here. So for us to make this more easier, so that we can easily visualize what it, we need to what? Draw what this structure. All right. We are not discussing organic chemistry yet at all. Please just know that it's just unfortunate that what we just have to what? Talk about it a little bit. Okay, so what we do, we draw the structure to make it what? More visible. So we're going to have C, all right, bonded to what? 3 hydrogen atom. All right, then we're going to have C bonded to what? 2 hydrogen atom. Then we're going to have C bonded to what? 3 hydrogen what? Atom. All right, so now what we do, we break what? The bonds. Remember, I told you that bonds are broken, and then we remove all the atoms surrounding what? The carbon atom by assigning oxidation number what? To them. Okay, so now you know the hydrogen is what? Is +1. If you break this bond, for example, if this bond is broken, right, it means hydrogen is what? +1, carbon is what? -1, isn't it? Isn't it? Remember, just a simple way to do this, let's say I have CH like this. We want to find the oxidation number of what? Of carbon. All right, so what we do is equal to what? 0, right? You know, you are looking for C, then plus H is what? Is -1, equals to 0, isn't it? H is +1, rather. H is +1. Okay, so carbon is what we're looking for. So C plus 1 is equal to what? 0. That means C is what? +1 comes this way, comes to what? -1, isn't it? So C is what? Is -1, H is what? Is +1. You get? So this is what we do for the individual carbon atoms. Now, let's see for this. When you break this carbon to hydrogen bond, we break it. Here is what? Is also negative. Sorry, -1. Here is what? +1. All right, -1 +1. If you break this bond here, right? Here is what? Yes, negative. Here is what? Positive. Okay, so that means what we do now, you now what? Calculate the bond of this carbon atom. Sorry, the oxidation number of what? This central carbon atom. If you calculate, this is what? Minus, this is minus, this is minus. So -1 plus -1 plus -1. Let me just put it out. This is the first and last time I'll do it. Having -1, then plus again, -1, then plus again, plus -1. So plus times minus here is minus, so -1 -1. Plus times minus here is also -1. So -1 -1 -1 is what? Is -3. That means that what? The oxidation number of what? This central carbon atom here is what? Is -3. Okay, remember we have to determine what the oxidation number of each of the central carbon atom. So now let's break what? This bond. Let's break this bond. All right, if you break this bond, here is positive, here is what? Negative, right? If you break this one, here is positive, here is negative. Okay, so now look at carbon to carbon or single bond, carbon to carbon, carbon to carbon. So if you break this bond, nothing will happen, right? Because what? There is no difference in electronegativity between what? These two what? Carbon what? Atoms, and therefore when we break this bond, like I've said earlier, it will not result to a charge on the carbon atom. So yes, what is 0? If you break this bond, it's going to be what? 0. So such that what? The oxidation number of this central carbon atom here is what? Is -2. All right, that is what? -1 plus -1, which is what? -1 -1, which is what? -2. Get? Okay, now for this one also, the same thing as this one. If you break this bond, yes, plus, yes, negative. Break this bond, yes, of course, negative, yes, plus. You break this bond, yes, what? Negative, yes, what? Positive. So yes, also what? -3. Hope we are clear with that. So what we do with that, what we break the bonds, remove all the what? Atoms surrounding what? The carbon atom, and then we will determine the oxidation number of the central carbon atom individually if you have more than what? 1 carbon atom in the compound. Okay, so that is the first example. Let's see another one. Let's see propane 1,2-diol. Propane 1,2-diol as another example. Let's say we're having CH3 CHOH CH2OH. Right, this is called propane 1,2 diol, or we also call it propylene glycol. All right. So we have something like this down, and then we want to determine the oxidation number for the carbon atom. So what we do also is to draw out the structure. So we have C, all right, bonded to 3 hydrogen atom. Then we have C, bonded to what? We have H here. Then up here we have OH. Then we have C, all right, have H here, here we have OH. All right, so it's simple. Now, the same thing we'll be doing is what we are still going to do. Okay, so determine the oxidation number of this carbon atom, and this carbon atom. Okay, now already we know, since it's bonded to 3 hydrogen atom, if you break this bond, yes, but yes, positive, yes, negative. All right, if you break this bond, yes, what, negative, yes, positive. If you break this bond, yes, positive, yes, what, negative. So that this carbon atom, this central carbon atom will be what, -3. That one is simple. All right, so now this carbon to carbon bond here is what? Is 0, right? Okay, we already distinguished that. So if you break this now, yes, positive, yes, negative. Okay, so if we break this, okay, what are we now going to have? This is where it now gets tricky. Okay, let's see. I have COH. It's not tricky. It's very easy. The same way we are doing it. All right. So once we break this bond, for example, let me draw it bigger so that you see. All right. All right. This is OH. If you break this bond, okay, what will be for the carbon atom? Oxygen has an oxidation number of what? Of -2. All right. Oxygen has oxidation number of -2. Hydrogen has an oxidation number of what? Of +1. Okay. So what to do? If you do this calculation, -2 + 1 is what? Is equal to what? -1. All right. That means what? OH itself has what? -1. If OH itself has what? -1. All right. -1. This means that C we have what? +1. Are we clear? Okay. So that means C there we have what? +1. Because reason, imagine you have what? Let's say COH. We want to find the oxidation number of carbon. Okay. So what do? You say C plus O is what? -2. Then plus what? 1 is equal to what? 0. All right. So C, plus times minus here is what? Is minus. Right. Let me bring it here. So I'm going to have C plus times minus -2. Then plus 1 is equal to 0. -2 plus 1 is what? Is -1. So C -1 is 0. -1 comes to this side. C is what? +1. All right. So the oxidation number of what? Of carbon here, right? When this bond is broken, is what? Is +1. So yes, what? Is +1. Yes, what? -1. Right. So you break this bond also. You break this bond. Yes, negative. Yes, what? Positive. Okay. Let's determine the oxidation number of this carbon atom. The oxidation number of the carbon atom is now what? +1, then -1. That is +1 - 1, which is what? 0. Okay, so that means the oxidation number of this carbon atom here is what? Is 0. Right now, for this one, you break this one, you have minus, you have plus. If you break this one, you have plus, you have what? Minus. Yeah. Then if you break this one, all right, you have plus here, you have what? Minus, just as I've done here. Okay, so that means if you determine the oxidation number of this carbon atom, yes, minus, yes, -2 now, then +1. This -1, -2, then +1. That is given out -1. Okay, as the oxidation number of what? Of that central carbon atom. So it's very easy to determine. Okay, so let's look at another third example to drive this point home. Let's use an example like pyruvic acid or 2-oxopropanoic acid. Okay, pyruvic what? Acid. CH3COOH, right? Pyruvic acid, CH3COOH. This is pyruvic acid. Pyruvic what? Acid, or call it 2-oxopropanoic acid. All right. Okay. Now, if I determine what the oxidation number of what? Of these carbon atoms in this compound, still we need to draw the compound correctly. You have C, here is H, here is H, here is H. All right, and you have C, you're bonded to O, then you have what? Bonded to what? C again, you're bonded to O, then OH. All right, so we have something like this, simple too. Okay, we already know that this carbon atom will be what? -3. Okay, we have determined CH3 already. So now if you break this bond here, okay, yes, -2 for oxygen, yes, what, yes, what, +2 now, okay, for what, for carbon. So here will be what, +2. Hope you understood that C double to O. If you break this bond, okay, the oxygen is -2. So I'm saying CO. Okay, so C plus -2 is what? 0. Oxygen is -2. So that C plus times minus is minus, -2 is what? 0. -2 goes that way. That C is what? +2. That's why having +2 here. So we'll break this one also. Yes, -2. Yes, what? +2. Okay. Then if you break this bond here, yeah. Yes, what? Minus what? -1. Yes, +1. Okay. I've done for COH in the previous example. So the charge on this carbon atom here was +1, +2, which is what? +3. Okay, so this is how what we assign oxidation number to what, to organic what compound. What we do is that what we break the bonds. Okay, after breaking the bond, we remove all the atoms surrounding the carbon atom by assigning oxidation number to what, to hydrogen, to oxygen, and to what, X, whether it's what is an halogen. Okay, and then we determine the oxidation number of the central carbon atom. Please, if you have not liked this video, what you are doing is very wrong. Liking this video will make other students easily find this video. If you have not subscribed, that is very bad, because subscription will send notification to your phone whenever we release a new video. And do not forget to share this video to your friends and loved ones. And I'll see you in the next episode. Thanks for watching.